Good morning, students. This is Murthy sir. Today, we will learn about one interesting topic, chemical bonding. The three theories of chemical bonding and ionic bond, covalent bond. These we are going to discuss today. Students, a chemical bond is an attractive force that holds two or more atoms together in a molecule or ion. Students, atoms combine to form molecules. Different types of molecules. Hydrogen is a diatomic molecule. Oxygen, a diatomic molecule. Nitrogen, a diatomic molecule. Students, if you take sodium chloride, it's an ionic compound. It is formed by the transfer of electrons between sodium and chlorine atoms. Sodium donates an electron and chlorine accepts an electron. As a result, Na plus Cl minus, an ionic compound is formed. The atoms of different elements, they form chemical bonds in order to attain the octet, that is 8 electrons in the outermost shell. To attain stability, they are participating in chemical bonds. Basically, there are two types of chemical bonds, ionic bond and covalent bond. In case of ionic bond, it takes place by the transfer of electrons. In case of covalent bond, it forms by sharing of electrons between atoms of different elements. Students, ionic bond is also called electrostatic bond or electrovalent bond. Ionic bond is stronger than covalent bond because of strong electrostatic forces which are present between the atoms of particular elements. Students, let us learn about the theories of chemical bonding. The first one is electronic theory of valence, proposed by Louis and Kozel. Second theory is VSEPR, valence shell electron pair repulsion theory. And the third one is valence bond theory. Students, second theory, VSEPR. It was proposed by Sedgwick and Powell, and it was modified by Gillespie and Naum. Third theory, valence bond theory, it was proposed by Linus Pauling. It is based on quantum theory. Students, the first theory, electronic theory of valence, proposed by Louis and Kozel. The basis for this is valence in terms of electrons. They provided logical explanation on the basis of stability or inertness of noble gases, and this led to the proposal of octet rule. Students, the discovery of noble gases and study of their properties is an important step in the study of different chemical elements. See, these noble gases, they are inert in nature. They will not react or participate in any chemical reaction because of their stability. They have filled octet, 8 electrons in their outermost shell, and they have no need to donate or gain electrons or share electrons. Students, Walther Kozel proposed ionic bond, and Jean Louis, he proposed covalent bond. So both are important contributions in chemical bonding. So different types of examples are there, ionic compounds and covalent compounds. Now let us see what is octet rule. The tendency of atoms to have 8 electrons in the valence shell is known as octet rule or the rule of 8. Students, here you can observe Louis dot structures of different elements. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Neon, you see, surrounding that 8 electrons are there in the outermost shell, filled octet. Students, neon is a noble gas, atomic number 10. Let us learn about ionic bond. Ionic bond is formed between atoms of two dissimilar elements due to the transfer of electrons from the atom of one element to the other. Ionic bond was proposed by Walther Kozel. Students, already I told, ionic bond is stronger than covalent bond because of the strong electrostatic forces which are present between the atoms of different elements. You take sodium chloride, there is an electrostatic force between sodium atom and chlorine atom. Because of this, it is a stronger bond. Students, when we observe sodium chloride molecule, sodium belongs to alkali metals, group 1 elements. It is a highly reactive metallic element. This chlorine belongs to halogens. It belongs to P block. It is a gaseous element. So there is an ionic bond between a metallic element and a gaseous element. So sodium is donating an electron to attain octet, and chlorine atom is accepting that electron to attain octet. Students, the transfer of electron between sodium and chlorine atoms in sodium chloride molecule, it results in a strong electrostatic bond or electrovalent bond. Students, what you are seeing here is representation of cation formation and anion formation. Positive ion is called cation and negative ion is called anion. Students, Na plus sodium ion, it is cation. Cl minus chloride ion, it is anion. Students, the sodium chloride being an ionic compound, when it dissolves in water, it dissociates into sodium and chloride ions. Students, the solution of sodium chloride in water, when it conducts electricity, it is called brine, B-R-I-N-E. Friends, what you are observing here is Louis dot structures of different ionic compounds. Magnesium oxide, calcium chloride, all these are ionic compounds, and here you can see the Louis method of representation of electrons around the atoms of those elements. Students, clearly you can understand magnesium is donating 2 electrons, and those 2 electrons are accepted by oxygen atom, and as a result magnesium oxide is formed. Students, here you can observe cation and anion formation in magnesium chloride, MgCl2. Here in magnesium chloride molecule, magnesium is donating 2 electrons, and those 2 electrons are accepted by 2 chlorine atoms to form MgCl2, magnesium chloride. Students, in the structure of chlorophyll pigment, an organic compound, magnesium is present. And you know, in the structure of hemoglobin pigment, iron is present. And these two are metallic elements. Magnesium belongs to alkaline earth metals, and iron belongs to D block elements, transition elements. Students, let us learn about the crystal lattice of sodium chloride. It is called face-centered cubic lattice. Here you can see the coordination number of sodium and chloride ions. Sodium ion is cation and chloride ion is anion, and both they have coordination number 6. The number of ions of opposite charge that surround a given ion of given charge is known as the coordination number of that given ion. In case of sodium ion and chloride ion, the coordination number is 6. A cation is surrounded by 6 anions, and an anion is surrounded by 6 cations. Students, now let us move on to the second type of chemical bond, covalent bond. This covalent bond takes place by sharing of electrons between atoms of same element or different elements. If you take hydrogen molecule, the sharing of electrons between 2 hydrogen atoms. Students, if you observe carbon dioxide molecule, CO2, covalent bond is there between carbon and 2 oxygen atoms. Students, Langmuir introduced the term covalent bond, and the study of covalent bonds of different molecules, it was introduced by Jean Louis. In case of ionic bond, it was proposed by Val de Courcelles. Students, here you can observe sharing of electrons in CO2 molecule. The sharing of electrons between carbon and two oxygen atoms. So it is a covalent molecule, carbon dioxide. Students, here you can observe Louis dot representation of some covalent molecules: hydrogen, oxygen, ozone, and nitrogen trifluoride, NF3. Students, here those dots represent electrons surrounding the different atoms of elements. Here you can see single bond in hydrogen molecule. Between two hydrogen atoms, a single bond is there. Two electrons are shared between two hydrogen atoms to form hydrogen molecule. It is a diatomic molecule. Students, you know, hydrogen is used as fuel in rockets and jets. It has high calorific value and it is highly inflammable. Students, here you can observe covalent bond in carbon dioxide molecule. The double bond between carbon and two oxygen atoms. Between carbon and two oxygen atoms, double bond is present. Students, double bond is sharing of two pairs of electrons. In nitrogen, three pairs of electrons are shared between two nitrogen atoms.